From Gauss's law applications, we have learned some formula. So electric field intensity near a charged wire of infinite length. The electric intensity is given by, at a distance r, lambda divided by 2 pi epsilon naught r. Well, lambda is linear charge density, charge per unit length, and the total charge on the wire is lambda into L. And for a uniformly charged jet sheet or planar sheet of surface charge density sigma, we have proved that electric intensity at a point near the plane sheet is given by sigma divided by 2 epsilon naught. And for a spherical shell of radius r, say positively charged here, if we choose a point here at a distance, say d, from the center, at point P, the electric intensity is 1 by 4 pi epsilon naught, magnitude of charge divided by d square. When point lies on the surface, here d is equal to r, then the same formula, that is on the surface, E on the surface, 1 divided by 4 pi epsilon naught, q divided by r square. 4 pi r square is surface area, charge by surface area, use what? Sigma. So that is sigma divided by epsilon naught is the intensity at a point on the surface. Many students will have some ambiguity in writing this. This is for a thin sheet, negligible thickness. You can imagine a paper, writing paper. Here the thickness is not same as of this. It has some certain thickness. For a thin sheet, sigma by 2 epsilon naught. For a charged shell of some finite thickness, sigma divided by epsilon naught. And when the point lies inside the shell, here charge is always residing on the outer surface. When point lies inside the surface, here charge is zero, therefore electric field inside is how much? 0. Here, for explain how the graph of, say, electric field, electric intensity versus distance vary in case of a charged spherical shell. For competitive papers, you need a graph. Out of 4 graphs, you have to choose a correct graph. Question is, graphical variation of electric intensity with the distance r. Means now you start from the center to the surface. This is a spherical shell, uniformly charged spherical shell. If you start from center to the point on the surface, inside the surface electric intensity is 0. Up to this point electric intensity is 0. When point P lies inside. When you go beyond the surface, means say from the center O here to here, say take D. When you go away from the surface, this distance d becomes greater than r. If you go beyond the surface, distance goes on increasing, and you have the formula E is equal to 1 by 4 pi epsilon naught q divided by d square. When point lies outside the sphere, this is the distance d from the center. From the surface, d increases means how they are related? Inversely related. Therefore, graphs is somewhat formed to be parabola. But on the surface, intensity is maximum, as we have studied just now. Electric intensity on the surface is sigma by epsilon naught. This is what? Small r is equal to d. Between these two, what you can write? R less than d. Here, if I choose this, beyond this distance d become greater than r. So out of 4 graph, the correct answer, variation of electric intensity versus distance, is the correct choice. A charged sheet. So it is positively charged. Say P is a point at distance say r from the plane sheet. What is the electric field at this point P? Electric field at the point P is given by, what is this? Charged sheet. Given by the formula sigma divided by 2 epsilon naught. What they ask? A charge q coulomb is placed at a distance r from the charged sheet. What is the force on this charge q? What is the basic formula? F is equal to E into Q. What is the formula for E now? E is equal to sigma divided by 2 epsilon naught into what is this? Q. Due to charged sheet, what is the force on a given charge? Your formula is EQ, sigma divided by 2 pi epsilon naught into Q. But here, as we studied in the previous problem, if they ask what is the torque on the dipole, here electric intensity at this point and at this point is what? Sigma divided by 2 epsilon naught. E is equal to sigma divided by 2 epsilon naught is the electric intensity, which does not depend on the distance. Does not depend on the distance. Here, from this to here, it is far away. You may look that this is far away. From here to here, it is near. But the electric field, I am writing the electric field away from this. This electric field, sigma by 2 epsilon naught, does not depend on the distance. Therefore, if I previous force on the charge is EQ, this is okay. Now, what is the torque? Theta is what? Angle between P vector and E vector. Torque and dipole is given by the formula P is sin theta. What is P now? Let us say Q is the charge, 2a is the dipole length, into electric field. What is electric field here? Sigma by 2 epsilon naught into sin theta. What is sigma? Sigma is charge density, that is total charge on the surface, let us say Q, divided by area, surface charge density. So torque on a dipole placed in an electric field. Now this electric field is produced by whom? A thin charge sheet. But in the previous problem, what they have given? Line charge. So which is positively charged here. So electric field due to this line charge at a distance x is given by the formula lambda divided by 2 pi epsilon naught into x. Line charge of linear charge density lambda and another line charge of linear charge density lambda 2. I have two line charges which are perpendicular to each other. Question is, at a point, if we draw this line makes some angle alpha here to say lambda 2. At point P means you can take x from the origin and at a distance y from the origin. Question is, what is this ratio? Lambda 1 by lambda 2. Question is, two line charges are kept perpendicular to each other at some point P whose coordinates are x, y. What is the ratio of linear charge density? Can you pause and answer for this? First, let me solve what is E1. What is E1? Because of this lambda 1 at point P means how far it is? X meter. Lambda 1 divided by 2 pi epsilon naught into x. For a line charge, E1 is equal to lambda 1 by 2 pi epsilon naught into x. Similarly, E2. What is E2? Electric intensity at point P. How far? Y from second line charge. What is the formula? Lambda 2 divided by 2 pi epsilon naught into y. Now what they ask, let us take the ratio E1 by E2. What is E1 by E2 now? E1 by E2 is equal to how much you get? So these two, 2 pi epsilon naught cancels. These two cancels. What is left now? Lambda 1 divided by what? Lambda 2 into what is this? 1 upon x by 1 upon y is y by x. Understood? Now again E1 I can write this as E1 here. At the point P, E1, and at the point P, this is E2. Now from this, if it is alpha, here also I can write alpha. Again, can you define what is E1 by E2 now? From this diagram, tan alpha, opposite what? E2, divided by adjacent. What is this? E2 by E1. Therefore, E1 by E2 is ulta. 1 divided by tan alpha equals to lambda 1 by lambda 2. Again, this from this geometry, you can have this is y, this one as x. So again y by x. Y by x is what? Tan alpha. So this is y by x is what? Tan alpha. Now what is asked in the problem? Lambda 1 by lambda 2. Lambda 1 by lambda 2. Tan. 1 by tan into tan. 1 by tan square alpha. So what is tan square? 1 by tan. Cot. Therefore, lambda 1 by lambda 2 is equal to how much here? Cot square alpha. By learning electric field due to line charge, what type of problems they may ask? This concepts and problems you must be thorough. Don't get feared. They are easy. Just try it. Once again you try it, it becomes easier. I have a line charge here. Say positively charged. Just kept like this. Means along x direction. Means along x direction electric field becomes 0. You will get the electric field along y direction, that is upward, radially outward. So what is the formula along y direction? Electric field along y direction becomes lambda divided by 2 pi epsilon naught into r. Question is this. This line charge will produce electric field lines in y direction and also in z direction. Let me write like this. Lambda divided by 2 pi epsilon naught into r. Let us choose r is the same here. Our distance r is same. How does the electric field lines looks if I cover all this? It encloses like a cylindrical shape. Question is this. Just below this plate, below this, or to understand easily, just you turn like this. It is easier to understand. Easily you can write the diagram also. Now there is a square plate here. There is a square plate. Square plate means all sides are equal. All sides are equal. From this point, how far? So that is root 3a by 2. At a distance, root 3a by 2 from the line charge, the electric flux, this is a line charge of length L, that is lambda is equal to Q by L. So flux is what? Electric flux is what? Q divided by epsilon. Flux passing through the surface. How? Normally. The flux through this surface is given as, what is Q here? Lambda into L. Lambda into L divided by N into epsilon naught. Question is, what this N number is? What are they given? This is a square plate, not a cylindrical shape, not a cylinder. It is of what shape? Square. You just imagine this chart paste box is a square plate now. You can imagine exactly what the problem is asked. These are the two edges now. Two edges. Of length how much? A. A. This distance is root 3a by 2. Now I just cut this. How much you will get? A by 2. I just draw perpendicular line. Here also. Perpendicular line. How much it is? This distance becomes a by 2 and a by 2. This portion is a by 2. This portion is a by 2. Can you guess what this angle is now? Here also. When you cut this length also a by 2. Half of this square. This distance is a by 2. This is a by 2. Here, distance of the point from the line charge. How much they have given? Root 3a by 2. This is what? Angle, let us say theta. Tan theta is equal to opposite a by 2 divided by root 3a by 2. A by 2, a by 2 cancel. How much you get? Root 3. So, tan theta is 1 by root 3 means, what is theta now? This angle should be how much? Tan 30. Tan 30 is sin 30 by cos 30. That is 1 by root 3. If it is 30, how much this is left? 30. So, what is the angle that is subtended by this square plate at the center? 60. I hope you understood this. Now this square plate has some electric flux through edges. You will have a cone formed here. Cone formed. This cone subtends how much angle here? 60 degree. But is the electric field lines around this line charge is only a square? No, it is what type? Cylindrical, all around. If I cross all around, how much is the angle subtended at the center? 360. 360. But this is only contributing how much angle? 60. Out of 360, it is contributing how much? 1/6. So this is nothing but lambda L divided by 6 times of epsilon naught. Have you got this number 6? Have you got? This flux that is passing through this given square plate which is at a distance of root 3a by 2, subtends how much angle here? 60 degree. But the field lines around this line charge is subtending how much angle? 360 degree at the center. Out of 360, it is only 60, means it is 1/6 of the total flux. 1/6 of the total flux means n should be is equal to 6. I have a circular disc. Circular disc of radius r. Now there is a charge q below the disc, circular disc. Means this is positively charged, means it is sending the field lines in all directions. 3D, that is means spherical way, in the form of sphere. So through this edges, the electric flux through this disc is 1/4 of the total flux. What is given? The electric flux by this charge passing through this disc is how much? 1/4 of the total flux. What is the total flux here? Spherical. If you observe, for a spherical surface, not for a circle, for a spherical surface, the angle subtended at the center is how much? 4 pi steradian. Angle subtended, denoted by letter omega. Angle subtended at the center of the sphere is how much it is? 4 pi radian. 1 steradian means angle subtended by hole. How you can define like this? That is total surface area divided by r square. Definition of steradian: total surface area by r square. What is the total surface area of this? 4 pi r square divided by distance square, cancel. Therefore 1 steradian is equal to how many radians? 4 pi. So what they have given, this 4 pi radian means entire sphere send how much flux? 5. 5 is the total flux. Now here this is becoming a part of the sphere. This portion is not the entire, it is not going to subtend 4 pi. This is going to subtend some angle here, which is not equal to 4 pi. Let us say this vertical line to the edge, one edge subtends an angle alpha. Subtends an angle alpha, and here to here distance they give b. Let us say b. Some letter they may provide. We are learning if this flux through disc is 1/4 of the total flux, we need to get relation between r and b. Question is this: what will be the relation between r and b when the flux through a disc is 1/4 of the total flux that is contributed by q? For this, you need a concept of steradian. That is, for 4 pi steradian, what is the total flux? 5. This is a semi-vertical angle of the cone. I will explain how to prove this. This semi-vertical angle alpha will subtend some angle at the center, which is small steradian, not exactly equal to 4 pi. The angle subtended by a semi-vertical cone. Semi-vertical cone is given by the formula 2 pi into 1 minus cos alpha. I will explain this, how you will get. We need some mathematical step. What is this? Angle subtended by semi-vertical cone. This semi-vertical cone forms how much angle? Alpha. What is the angle subtended here? D omega, small, not total. How much it is? 2 pi into 1 minus cos alpha. You are learning relation between R and D. R is the radius, D is the distance of the charge from this. For d omega, 2 pi 1 minus. What is cos alpha here? Cos alpha. Adjacent side divided by hypotenuse, that is root of b square plus r square. Root of b square plus r square. I will explain this how you are getting. You may wonder how this comes. I will explain in detail. This is not full steradian, only some angle subtended by the semi-vertical cone, not the entire cone, not this entire cone. Semi-vertical cone, this portion. How much is? 2 pi into 1 minus cos alpha. What they have given? The flux through this disc is 1/4 of phi total. Therefore, for 4 pi, how much is the flux? Phi. 4 pi. For 4 pi, what is the flux? Phi. Therefore, for d omega, how much is the flux? For d omega, how much is the flux? That is, you have to solve for this. Phi dash will be equal to phi this into d omega divided by how much? 4 pi. For 4 pi means for full spherical surface. What is the steradian? 4 pi. What is the total flux? Phi. But we need what is the flux that is for an angle of how much? D omega. So that is phi dash will be equal to phi into d omega by 4 pi. Now what is they have given? The flux passing through this disc. Through this. How much they have given? 1 by 4 of Q total. 1 by 4. That is phi divided by 4 equals to phi divided by 4 pi into d omega. What is d omega here? I have to substitute this. Have you understood this? Feel it. Do you feel this difficulty? No, you have to memorize this. In JEE papers, definitely this type of problem will be there. Definitely. What cancels here? 5 by 4 cancels. From this, what do you get down? 5 by 4. So pi is equal to d omega. Pi is equal to, what is d omega here? 2 pi into 1 minus b divided by root of b square plus r square. What is cancelled? Pi cancels. So how much you get? 1 minus b divided by root of b square plus r square is equal to 1 by 2. Then do mathematics. 1 minus 1 by 2 is equal to b divided by root of b square plus r square. What is left now? Left side. 1 by 2. 1 minus 1 by 2. 1 by 2. b divided by root of b square plus r square. Taking square on both sides means you will get 4. B square is equal to b square plus r square. So 3b square is equal to r square. Therefore, b square is equal to r square by 3. B is equal to r divided by root 3. Now let me explain how this d omega is equal to 2 pi into 1 minus cos alpha. Better to memorize this while doing the problems. To understand this, what we have taken? A disk. From this disk R, take a small strip of a radius R, small disk of radius R, remove it. Let us say this thickness is dx. Take it out. You cut at one side, you extend this. Among big circular disk of radius R, you have taken a small disk of radius R with a small thickness dx. Means what is the circumference here? Circumference gives the total length, 2 pi r. What is this? Into dx. This elemental strip of width how much? Dx will subtend say an angle, small angle d theta. This small strip, you can imagine like this, small strip will subtend an angle d theta. This r, let us say this distance is also r now, here to here, r. And this semi-vertical angle formed by the cone is what? Alpha. This entire, this is how much it is? Alpha. This semi-vertical angle formed is how much? Alpha. But this is divided partly, how much? D theta. Let us choose this theta. If this elemental strip is at this point, theta becomes how much? 0. When this elemental strip comes over here, theta is variable, initially 0. When this element goes away, when it comes to the entire disk, when this elemental strip comes over here, this theta becomes how much? Alpha. Means theta is varied between 0 and alpha. Understood? And this r is what? Radius. For this theta, this r becomes what? Opposite. This line is radius. This is 90, hypotenuse. 90, opposite, hypotenuse. This is r, opposite side. Therefore, r becomes equal to how much? R sin theta. So therefore, this value 2 pi, r becomes what? R sin theta. What is steradian? It is the total surface area by r square. Now what is the surface area of the disk now? Surface area of the disk. Length is how much? 2 pi r. 2 pi r. R is what? R sin theta. What it gives? Length. Into breadth. Length into breadth gives what? Area. Dx. This is dx. This dx subtends how much angle here? D theta. Length of arc dx is equal to r d theta into dx. This gives what? Area. What is dx here? Dx is r d theta divided by here to here. How much it is? R square. Integrate. Because this d theta is variable. D theta is variable from where to where? From 0 to alpha. So integrate from 0 to alpha. R square cancels. What is left now? 2 pi Sin theta d theta. What is the integration of sin theta? Minus cos theta. Minus cos theta. Cos theta. Theta is varies from where? 0 to alpha. Minus 2 pi. Upper limit is what? Cos alpha. Minus lower limit is what? 0. Cos 0. Cos 0 is how much? 1. Simplify multiply. Cos 0 is 1 minus equal to 1. 2 pi into bracket 1 minus cos alpha. This is what? Small solid angle subtended by semi-vertical cone formed by an angle alpha. Derivation kelala, but if anybody asks how, just follow this. Now onwards, so after learning this, problems becomes easier now.